All right, ladies and gentlemen, this is our lesson 7.2.2. So you would have this packet in front of you. Please follow along, take notes with it as we go. And this will be our lesson for today. Our lesson 7.2.2, how does y change with respect to x? So slope, can you imagine swimming 1.5 kilometers? That's just less than a mile. Getting dressed as fast as you can, hopping on a bicycle to race 40 kilometers, that's almost 25 miles. Then getting off your bike to run 10 kilometers, that's just over 6 miles. Athletes who compete in Olympic distance triathlons do exactly that. In the 2008 Summer Olympic Games, Jan Frodeno of Germany won the gold medal by finishing the triathlon in 1 hour and 48 minutes and 53.28 seconds. Frodeno did not finish the swimming section in first place, though. In fact, he was not even one of the first 10 people to finish the part of the race. While Frodeno may not have been the fastest swimmer, what mattered most was his overall rate. As you compare rates today, you will learn a new way to describe the growth rate of a line called slope. As you investigate rates of change, use the following questions to facilitate mathematical discussions with your team. How can I use the graph to figure out which racer is faster? How can we find the unit rate for each racer? What if the line does not pass through the origin, or 0, 0? So that leads us to our first problem, 731. The second part of the triathlon is a bicycle race. Since participants do not start the bicycle race until they complete the swimming portion, the bicyclists have varying starting times. Based on the graph to the right, this is part A, list the bicycles from slowest to fastest. How can you tell? So we're looking at this graph right here. I would recommend making a pause and trying to answer this question before we go over it. So when we're looking at these lines here, guys, we are looking for the steepest line. The steepest line is actually the fastest line. Slope is another fancy way that we can describe speed. So they are related to each other. When we're looking at this graph, it looks like the steepest of the lines is B. And kind of maybe the flattest line looks like it could be D. So the flattest line would be the slowest. Let me write a little mark here though. I said speed or slope is based on the steepness of the lines. So if we're ordering them from slowest to fastest, we would see that the slowest line is D, because it's the flattest. If you look, B is the steepest, so that means A and C are between it, but A and C look like they're parallel to each other. If they're parallel to each other, that means that they are the same. So A and C are the same, and then we would put B is the fastest. So slowest is D, A and C are the same, and B is the fastest. Make a pause if you need to, and then you can get caught up with our notes. Moving on to part B, Lydia wants to describe each bicyclist's rate in kilometers per minute for an article in the school paper. To do this, she sketched triangles like the one for the line A on the graph at the right. So that's right here. Where do the 4 and 6 come from on Racer's A triangle? What do they represent? Remember in our previous lesson, guys, I said that we have to use lattice points. Lattice points are the points that cross perfectly in the corner out of these grids. That's how we can count our slope. So what the 4 and the 6 represent is, those are the side lengths of the triangle, otherwise known as rise over run. And rise over run is a way that we can represent the slope. So in this case, the rise might be 4 and the run is 6. So the rise over run would be 4 over 6. However, those are both even numbers, so it can be simplified down to make an equivalent expression. You can take a 2 out of the top and bottom. Our slope or speed would be 2/3 for our example. Well, that represents the slope. And then, so make a pause if you need to. But moving on to part C. Did the slopes in part B confirm your ranking from the slowest to fastest in part A? Well, we don't know the speeds of our lines in part A, and not gonna lie, this graph is kind of hard to see. So I went ahead and I calculated out the speeds for us. So I'd like you to please get these down because they will help us on our next problems here. Speed B, our rise over run was 3 over 3, which is equivalent to 1 over 1. But 1 divided by 1 is 1. 3 divided by 3 is also 1. So our speed of B is 1. Speed A and C. Our speed of A and C has a rise of 2 and a run of 3. 2/3 cannot be simplified. That's an even and an odd number that are in its simplest form. That's our speed. So then last but not least, we need to find the speed of D. So speed D, it is a rise of 2 and run of 4. Now 2/4 can be simplified down to 1/2, because you can take a 2 out of the top and the bottom. So we got 1, 2/3, and 1/2. So when we were trying to decide what our rank is, if the slowest is D, I would say D is the slowest because it's 1/2. A and C are the same of 2/3. 2/3 is greater than 1/2, and 1 is for sure greater than any fraction that we would ever be given. So this confirms our part A. We will still need these numbers coming up, so please make sure you get these down and make a pause if you need to, but we're going to move on to 732 here. Alright, so in 732, looking at your biking the triathlon problem 731, slope can also be thought of as a unit rate. For those of you that don't remember what a unit rate is, we're going to rewrite them here. So our speed in A, recall, was a fraction of 2/3, so it would be 2/3 kilometers, and it's over a unit rate, so that'd be per 1 minute. That's a unit rate. It's a distance over time that's at the unit of 1. B is 1 kilometer over 1 minute. C would have been 2/3 kilometers over 1 minute because A and C were exactly the same. And then D is 1/2 kilometers over 1 minute. So remember that a unit rate compares the change in one quantity to a 1 unit change in another quantity. In B, we can actually round these to a decimal too. So 2/3, you can take 2 divided by 3, it's going to give you a decimal. Divided by 1, it's just going to be that decimal. That's what makes unit rates so cool. If we're going to convert A to a decimal, we would get 0.67 kilometers per minute. B, 1 kilometer divided by 1 minute is 1 kilometer per minute. C would also be 0.67 kilometers per minute. And then D, 1/2 divided by 1, that would give us 0.5 kilometers per minute. So our bikers and bikers A and C were both traveling at 0.67. Biker B was traveling at 1 kilometer per minute, and biker D was 0.5 kilometers per minute. So once again, if looking at speeds or slopes, because speed and slope is the same, you can see that biker D was the slowest. A and C were going the same exact speed, but a little slower than B, because B was our winner. B was the fastest. Make a pause if you need to, but we're moving on to 733. While comparing the race from problem 731, a study team is struggling to decide how to tell which athlete is moving faster. Leo thinks that because athlete A's line is highest on the graph, he is traveling faster. Kara disagrees. He starts first, but racer B is clearly moving faster. Which person do you agree with? Look at the graph of bicyclists A and B below and discuss with your team. Be prepared to explain your reasoning to the class. You know, we are doing this solo today, so maybe make a pause. Think who's right, Leo or Kara. I'm assuming you took a pause. I hope you took a pause. But if you said Kara, you are correct. So we're going to write Kara is correct. We have to justify, though, and we have to say why. So we can say line A starts at a closer distance. This is true because line A starts at, looks like, at 7 kilometers in the race, and line B started at 0, because that was our measure on the Y. However, remember, speed and slope is measured by the steepness of the line. Line B is clearly more steep. If you put a marble at the top of this line, it's going to roll a lot faster on B than it would on A. So we're going to say line B is clearly more steep than line A. Therefore, line B over line A. Speed-wise, that's our justification. If you have something similar or along the lines to that, that's totally okay too. This is just Cosbo's description. If you need to, make a pause, but we're going to move on to our last problem. This is certainly a problem that I believe you can do alone if you would like to. But here's the video answer of it as well. This is a throwback to Chapter 4. In problems 4.8 and 4.10, you looked at how tile patterns grow. You examined how the growth rate could be seen in the table graph and rule for a pattern. One patterns that you looked at and its graph are shown below. So remember what I said, my little hack was I said count up the tiles. We have 1, 2, 3, 4, 5, 6. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What is the growth rate for this pattern? How can you tell? You're looking for the change in these numbers. From 2 to 6, we know that's a +4 change. From 6 to 10, we also know that's a +4. And from 10 to 14, we know that's changing by +4. So the growth rate for this pattern is 4. How can we tell? Well, pretty simply, the pattern is changing by 4. Now, what is the slope of the line graph? How does this value compare to the growth rate for this pattern? Well, guys, slope means the same thing as growth rate. I mean, there's lots of terms that can be coined in this situation. Slope can be growth rate, slope can be pattern, slope can be change, you name it. So in this case, guys, slope is 4. You can even say +4 if you want to be specific. But because I think this problem is too easy, guys, I'd like you to try to make an equation based off of this information. Make a pause. Now make your equation. I will display the answer here. We got y equals, our slope is 4. That goes next to the x. Now remember, our y-intercept is the number that lines up with figure 0, so it would be 2. So the equation is y equals 4x plus 2. Something that is totally review for you guys. Alright, if you are all done with today's lesson, please be respectful to our sub. You may complete and work for our class. Any missing homework, it should be on Schoology. Otherwise, I hope you wrote it down. Maybe you can get it from a neighbor. You can also work on other work for other classes. There is no phones, as always. Please stay on task. Have a great day. Thank you, everybody.